All right, so we want to factor these equations by difference of squares. So this first question here is pretty simple. It's a review of grade 10 math. All we have to do is square root each term. So square root of x squared is x. Square root of 9 is 3. So my solution is just x plus 3 times x minus 3. Basically, the terms are the same, but the signs are going to be opposite in each bracket. Same idea here. This one's a pretty simple one. The square root of 4n squared is 2n. Square root of 49 is 7. So 2n plus 7 times 2n minus 7. Gets a bit more difficult in this one here, but let's do it. Square root of x8 is x4. So x4 plus 1 times x4 minus 1. Now this can be factored further because x4 minus 1 can be factored by difference of squares. Remember, you need a minus sign. You can never factor a plus sign. So this first term is going to be the same. And this is going to turn into x squared plus 1 times x squared minus 1. If we look at this, we can factor this term again by difference of squares. I'm going to have the first term the same, the second term the same, and this is going to turn into x plus 1 times x minus 1, and now this is fully factored. For this fourth one here, there's a plus sign in the middle, there's also a negative sign in the front, so I like to factor out the negative to begin with. You're left with p squared q squared minus 81. And now I can factor this with difference of squares. Square root of p squared q squared is just pq. Square root of 81 is 9. Here I have pq minus 9. Fifth one here, this is a difference of squares, but it's a bit hard to tell because we have a bracket here. So I like to do a substitution first. I'm going to say let a equal to whatever my bracket is, in this case, y minus 1. So now I can rewrite this equation as 9a squared minus 25. And now it's a lot easier to tell that you can do difference of squares here. Square root of 9a squared is just 3a. Square root of 25 is 5. So I have 3a plus 5 times 3a minus 5. And now I need to sub back a for what I originally subbed it for. I'm going to replace the a's over here with y minus 1. Oops. And now you just want to get rid of these internal brackets. So I'm going to multiply 3 into these brackets. So 3y minus 1, minus 3 plus 5, 3y minus 3 minus 5. And then last step, I'll combine like terms in these brackets. I get 3y plus 2 and 3y minus 8. And this is my final factored solution here. Last question, same idea. I have a bracket over here, so I'm going to start with substitution. Let a equal to 2 minus x, and I'll rewrite my equation as 3x squared minus 27a squared. Now, what you notice here is 3 and 27 cannot be square rooted, but it can be common factored out. So I can common factor out a 3, and I'm left with x squared minus 9a squared. And now I can factor this with difference of squares. So I have x plus 3a and x minus 3a. Then I need to come back and sub in the a as 2 minus x. X plus 3, 2 minus x. And x minus 3, 2 minus x. I'll get rid of my internal brackets next. X plus 6 minus 3x. Then x minus 6 plus 3x, and last I'll combine like terms. So here I'll get 6 minus 2x. Here I'll get 4x minus 6. Now, usually this is the final solution to the question, but we have a little bit of an exception here. If you notice, I can factor a 2 out of this bracket, and I can also factor a 2 out of this bracket as well. So 3 times 2 is 6, times another 2 is 12. So I'm going to have 12 out here. This becomes 3 minus x, and this becomes 2x minus 3, and now this is my final solution.